We've brought something interesting for you again in this video. Please endeavor to watch to the end. We are going to be looking at Kirchoff's voltage law, and the question is for us to determine the current flowing in the circuit below. We are given the circuit to determine the current flowing in the circuit. We are just going to apply the Kirchoff's voltage law in this particular exercise. Watch. When you have a question like this, the first thing you want to do is to assign the positive and negative signs to the voltage source. Remember, for a battery or a cell such as this, the longer line is the positive side while the shorter line is the negative side. So let's start with this. It means this side is positive, this side is negative for this battery. Similarly, for the 8 volts, this is positive, this is negative. Now that you've done that, the next thing you want to do is to assume a direction of current flow in this loop. Kirchoff's voltage law is applied in a loop. A loop is a continuous or a closed path of current flow. So if you look at this, there is a closed path for current to flow. So current can flow in this closed path. So we call this a loop. Kirchoff's voltage law is always applied in a loop. So what we need to know is to identify the current flowing in the loop. And you will assume a direction of current flow to start with. In this video, I am going to assume that the current I is flowing in the circuit in a clockwise direction like this, as you can see, as indicated by the arrow. I am assuming that current is flowing in the loop in a clockwise direction. You can feel free to assume that current is flowing in an anti-clockwise direction. That is equally fine. But the most important thing is make sure that you assume a direction of current flow. At the end of the calculation, your answer will be able to tell you whether the current is flowing as assumed or is flowing in opposite direction. So we can determine the actual direction of current flow at the end of the exercise. But to solve the problem, we need to assume a direction of current flow in the first instance, and that is what I've just done. After identifying the direction of current flow, the next thing you want to do is to assign a positive and negative sign to each of the resistors you will find in that loop. Remember, Kirchoff's voltage law means the law you are applying is applied to voltages. These are voltage sources, while resistors are points of voltage drop. As the current is flowing through the resistors, voltage will be dropped across them. So those voltages are what you need for the KVL. How do you identify the positive and the negative sides of the voltage that will be dropped across each of the resistors? Starting with 2, just look at the direction of current flow that you've assumed. We assumed is flowing clockwise. That means current will appear to enter into these 2 ohms resistors from this point. Anywhere in the component or the resistor where current appears to enter, label it positive and the other side negative. Which means for this 2 ohms resistor, since we assume current flowing like this, I will call this positive, negative. Current flowing like this, so I will call this positive, negative. Now we have signs assigned to each of the components. We can now apply KVL. So applying KVL in the loop simply means, let's talk about what KVL is. KVL simply means the algebraic sum of the voltages in a loop is equal to 0. That is the Kirchoff's voltage law. It states that the sum of all the voltages in a given loop must be equal to 0. So now let's add up the voltages. Remember, there are signs to each of them, so let's add up carefully. One good way to do it is to take the signs this way. If you assume current is flowing like this, wherever current appears to enter into a given component, pick that sign. It means for this 12 volts, the current is appearing to enter from the negative side. So I'm going to pick negative for this one. So I'll call negative 12. I'm done with this. For this one, it is entering from the positive side. So I'm going to pick positive. Remember, voltage drop means current times resistance. So I times 2 will give me the voltage drop here. So it will be 2I. but it enters from the positive, so I will say plus 2i. For 3 ohms, it enters from the positive, so I will say plus 3i. While for 8, it enters from the positive, so I will say plus 8, and everything is equal to 0. So this is KVL for you in a form of equation for this given circuit. Now you have a simple linear equation. All you need to do is to solve for the value of I. 2i plus 3i gives us 5i. This negative 12 transposes to the right hand side is 12. Positive 8 to the right hand side, negative 8. 12 minus 8 gives us 4. So 5i equals 4. To obtain the current I, we divide both sides by 5. So that I will be 4 divided by 5, and that is 0.8 ampere. So the current we are looking for in this question, which is the current flowing in the circuit, is simply 0.8 ampere of current. Now take note, if you assumed that the current was flowing anti-clockwise in the first instance, you are still going to get 0.8. However, you will get minus 0.8. The negative does not mean you are wrong. It only tells you that the current is flowing in the opposite direction to your assumption, which means if you assumed clockwise, the actual direction of current flow is, if you assume anti-clockwise, the actual direction of current flow is clockwise. That is what the negative would mean. We assume that the current is clockwise, and actually we got a positive answer, which means the actual direction of current flow is clockwise. So this is the answer to the question. If you understood this exercise, then solve this simple one. Try this. Find the current in the circuit below and put your answer in the comment section. This is exactly like this. However, take note of the 8 volts battery source. I have changed the direction of the battery. It is now different from this. So take note of this while solving this problem. If you enjoyed this video, please like it, share it to your friends and learning colleagues, and most importantly, drop your comments in the comment section. Follow our page if you have not done so, and if you are watching us on YouTube, consider subscribing. That way you keep encouraging us to make more interesting and educational content for you. Once again, thank you for watching and hope to see you in our next video.